Hello and welcome to Notification! On today's episode, we are going to talk about the compressibility factor, otherwise known as Z. So, the compressibility factor is basically the deviation between the behavior of an ideal gas and a real gas. So, since it's easy to calculate how an ideal gas will work, we can use the compressibility factor to try and calculate how the real gas will work using the different pressures and temperatures that's occurring on the gas. On today's episode, I have two special guests, Seppo Putile and Tumelo Moshidi. They are world-renowned mechanical engineers, and I'm glad to have them on the show today. First, we have Tumelo with an explanation behind the variables of compressibility, and then we have Seppo, who's going to explain to us how to get Z, or compressibility, from the common thermodynamic tables.
Good day. I'll be making a presentation based on fluid compressibility. On this topic, I'll be more focused on compressibility factor, which is denoted by Z. Z can be calculated by the formula which says that Z is equal to PV over RT, where Z should be unitless after the calculations. From this formula, we have to note that P represents pressure of the fluid, V specific volume of the fluid, R universal gas constant, and T represents temperature, and where Z represents compressibility factor, which is always unitless. From this, we have to note that compressibility factor Z is more influenced by reduced pressure, which is PR, and reduced temperature, which is TR. From the compressibility chart, that's where we will extract the value of Z after calculating our PR and TR. We have to note that Z, when temperature is fixed and pressure approaches 0, the limit of Z will be equal to 1. Thank you.
Good day. I'm going to explain how to extract Z, which is a compressibility factor, from compressibility chart. Explaining in 3 steps of really how to find Z. First step, calculate critical pressure and critical temperature of the given substance from table A1, which is on our right hand side of the page. Second step, you're going to use the formula for reduced pressure and temperature to calculate the reduced pressure and temperature. And then the last step, you're going to use those calculated reduced pressure and temperature values to extract Z from compressibility chart. Through the worked example, given ethylene at 38.85 degrees Celsius and 10,300 kilopascals, we determine the value of Z. As the given data, and also we're using the table A1 to obtain critical pressure and temperature, where the critical pressure of ethylene is 51.2 bar, which results to 5,120 kilopascals, and temperature to 283 Kelvin. Our calculations result to reduced pressure of 2.01 and reduced temperature of 1.10. And then hence we go to our compressibility chart to extract the value of Z. And then when we reach to our compressibility chart, we see that our reduced pressure is on the x-axis, and then our compressibility factor is on the y-axis. So on the x-axis, we go to 2.0, which is our reduced pressure, and then we go up with it until we meet the line for reduced temperature of 1.10. And then when we meet it, we go to the left, corresponding to our compressibility factor of a value of 0.4, which is our compressibility factor value.
Awesome. Thank you so much to Tumelo and Seppo for their insights on compressibility. It was very educational. As you can see, the further the compressibility factor is from 1, meaning going downwards from 1, the higher the deviation between the real gas and ideal gas behavior is. So basically, the deviation depends on the temperature and pressure acting on the gas. Thank you so much, guys, for watching the video. If you have any questions, please message down in the comments. I'm sure I won't be able to answer them, but I'll ask my two engineers to answer them. And yeah, enjoy your day.